Today's lesson in Unit 11, Lesson 10, the tangent function and Pythagorean identity, found on pages 384. We'll be covering 2.5 pages, pages 384, 385, and the top of page 386. Be helpful if you had a highlighter in your calculator. The two most important trig functions are sine and cosine, but recall there's a third trig function known as the tangent. Let's recall how it was defined using right triangle trigonometry. Remember SOHCAHTOA? TOA, the O is for opposite, A is for adjacent. So the tangent of angle theta is equal to the side opposite divided by the side adjacent. Tangent equals opposite over adjacent. You have to know that. In relation to angle theta, opposite the side, it's just that adjacent is next to, and this was the hypotenuse. For each of the right triangles below, state the values of sine theta, cosine theta, and tangent theta. We could use Pythagorean theorem to find the other leg here, or this is one of our Pythagorean triples. This is a 3, 4, 5. So this leg here is 3. In relation to theta, well, first, the hypotenuse is 5. That's always opposite the right angle. And in relation to angle theta, 3 is opposite, and 4 is the adjacent side. Sine of theta equals opposite over hypotenuse, which would be 3/5. Cosine of theta, adjacent over hypotenuse, 4/5, and tangent of theta equals opposite over adjacent, 3/4. For B, this is not a triple, so we'll use the Pythagorean theorem to find the length of the other leg. Or you might, you might recognize this as a special right triangle from geometry. But anyway, let's see. So we'll do 1 squared plus b squared equals 2 squared. 1 plus b squared equals 4. Subtract 1. B squared equals 3. And then take the square root. So b equals the square root of 3. 2 is the hypotenuse. The square root of 3 is the length of the leg opposite angle theta. And 1 is the length of the leg adjacent. Sine of theta equals opposite over hypotenuse, square root of 3/2. Cosine of theta, adjacent over hypotenuse, 1/2. And tangent of theta equals opposite over adjacent, square root of 3/1, which is the same as square root of 3. Okay, now just as with sine and cosine, we can also define tangent in terms of the unit circle. Right? Consider the unit circle shown. Answer the following questions based on this diagram. If x, y represents a point on the circle, how can we define the tangent of the function in terms of this point? Okay, this y got cut off here. So this is opposite, and this is adjacent. So tangent is equal to opposite over adjacent, which in this case, looking at this right triangle, opposite is represented by y, and the length of the leg adjacent is x. So tangent of theta equals y over x. Given how we define sine and cosine, how can we define tangent function in terms of sine and cosine? Well, we know when we are on the unit circle that x is equal to the cosine of the angle and y the sine of the angle, so tangent theta is equal to sine theta over cosine theta. And that you want to memorize. So sine theta over cosine theta. our x coordinate over our y coordinate. Sorry, that was wrong. Our y over x. Y coordinate over x coordinate. A circle with its center at the origin and its radius of length 1 is our unit circle. If point P, x comma y is a point on the unit circle, then x equals cosine theta and y equals sine theta and tangent equals sine over cosine. If we are on the unit circle, you want to memorize these three things. Because the tangent function involves division, there's a chance it could be undefined. That occurs when we have 0 as a denominator. Consider the angle theta of 90 degrees, which is equivalent to pi over 2 radians. State the values of sine and cosine of this angle. Okay, so the sine of 90 degrees, I go on the unit circle. The coordinate is 0, 1. Sine is going to equal the y coordinate, so sine of 90 is 1. The cosine would equal the x coordinate, which is 0. The tangent of 90 is equal to sine over cosine, which would equal 1 over 0. And that's why it's undefined. Why would the value of tangent 90 be undefined? Because we have 0 in the denominator. 1 over 0 is undefined. Exercise 4. At which of the following angles is tangent undefined? Okay, 0 degrees, I'm thinking of the point, 1, 0. So tangent is going to be undefined when cosine of the angle is 0. Cosine sine, 270 degrees, thinking of the point 0, negative 1, so that would be it for 270 degrees. Next thing, Pythagorean identity. For any angle theta, the cosine of theta squared plus the sine of theta squared equals 1. You must memorize this, and we also will be applying this to situations. If we know the sine or cosine of an angle and the quadrant of the angle, we can find the other two missing trig values. Determine the value of cosine theta and tangent theta if sine theta is equal to 5/13 and the terminal ray of theta lies in quadrant 2. Using the Pythagorean identity above, if we have, let's write, and it's usually written this way, cosine squared theta plus sine squared theta equals 1. We can find cosine by using the identity. Substitute 5/13 in for sine theta. We'll square that. Cosine squared theta is equal to, I'll subtract this, 1 minus 5/13 squared. Grab the calculator. One minus 5 divided by 13 squared. Math fract that. Oh, actually no, we want to take the square root next. Let's see what happens. I'm going to do both. I'm going to math fract it. Get that. And now the square root So cosine of theta equals plus or minus, that's going to be 12/13. And we are in quadrant 2, where cosine is negative. So the cosine of theta is equal to negative 12/13. And the tangent of theta, put it over here, equals sine over cosine. We're in quadrant 2 where tangent is negative. So this would be negative 5/13 over, well, we already had the negative 12/13, so I'll just leave that. And when these denominators here, so we have a fraction, we have two fractions within a fraction. When the denominators are the same, they just kind of divide out. So the tangent of theta is negative 5/12. Okay, so that's one way of using the Pythagorean identity. The other way of doing this problem is to take the information here. We are in quadrant 3. We're in quadrant 2, and draw a right triangle in the given quadrant and use SOHCAHTOA. So in quadrant 2, draw a right triangle. Here's angle theta. The sine of theta opposite over hypotenuse is 5/13. So this is a 5/12/13 Pythagorean triple. So now we have the length of the adjacent side. The cosine of theta is equal to adjacent over hypotenuse, which would equal 12/13, where we are in quadrant 2, where cosine is negative, so negative 12/13. The tangent of theta is equal to opposite over adjacent. Opposite is 5, adjacent is 12, and we are in quadrant 2, so we have negative 5/12. So either drawing the right triangle in the correct quadrant or using the Pythagorean identity will arrive at the answers we are looking for. And our last exercise, number 6. If cosine of theta equals a, where a is greater than 0, and the terminal ray of theta lies in the 4th quadrant, so we are in quadrant 4, then which of the following gives the value of tangent theta in terms of a? We'll use our Pythagorean identity. Cosine squared theta plus sine squared theta equals 1. Cosine of theta is a, so we have a squared plus sine squared theta equals 1. Subtract a squared from both sides. Sine squared theta equals 1 minus a squared. And now take the square root of both sides. Sine of theta equals plus or minus the square root of 1 minus a squared. We're in quadrant 4, where sine is negative. So the sine of theta equals negative square root of 1 minus a squared. Tangent of theta equals sine over cosine. You have to know that. Memorize that. So we have tangent theta equal to negative square root of 1 minus a squared over cosine theta was A, which matches choice 4. Thank you for your attention.